Very good morning. Today we are going to see about the same economic load dispatch problem for complex functions. So if the fuel cost function, like previously we have seen about fuel cost function as Fi of Pi is equal to Ai Pgi squared plus Bi Pgi plus Ci. Okay, so only the generation we have taken like AI PGI square. So if say for example that problem itself complex. So why? Because we are taking only 3 generating units for solving that problem. Okay, so that's why we are taking some half an hour, minimum half an hour to 20 to 25 minutes to solve those problems. So if we are going for 10 unit system, the same problem, 10 unit system, the time involved in solving that problem goes, okay, because you need to find out PG1, PG2, up to PG10 you need to find out. Okay, time involved in that particular thing will be very more. Okay, so even 10 is okay. Then the time involved will be like instead of half an hour, it might take 3 hours also. Okay, 3 to 4 hours also for finding out if you are doing with pen and paper. Then again, if you are going for 100 unit system, again this complexity get increased. Okay, again 1000 unit system, like that this complexity will get increased. Okay, so the matrix will not okay, even though if you are programming in MATLAB, sometimes your matrix dimension will agree. Okay, so 100 cross 100 matrix you need to frame. Okay, so sometimes the time involved in the problem will be increasing. The complexity of the problem is increasing. Even in that case, say for example, in that scenario, even the fuel cost function also becoming complex, then the complexity will increase further. Okay, the complexity will increase further. Again, you need to frame the problem solving time will take more, and only like few generating systems, say for example 2 generating system, 3 generating system, that is very easy to solve. Again, if you go for 10 generating unit system, 20 generating, then 100 generating units, then the time involved might be of 10 hours, like it might be increasing like anything. So that's why we are going for programming. Even the programming also will have to certain extent you can easily program. So even the generating unit size might be increasing like anything. Then again, say for example, if you take the number of generators in whole India, the total number of generating units, or total number of generating units. So like that stage by stage generator might be there. So in one generating unit, like minimum 4 to 5 generating units are there. If you take like almost all the generating units in all the states and all over the country, then the maybe it might be coming, like the number of generators might be coming off like 400, 500 generators. So if 500 generators you are going to do the problem with the demand, say for example certain demand is being given, so 500 generators you need to dispatch, and you need to find out the least cost generator. Then the complexity of the problem will be very more. Even in our state, say one state itself, if you take the number of generators with the demand and with the constraints, okay, then like without the constraints, if you're neglecting certain constraint and you are solving the problem, then somewhat you can get. But with considering all the constraints, we'll discuss in one class. There are many constraints. I didn't tell you those constraints, like complex constraints are there. So only we have taken only easy constraint, like power balance constraint, minimum and operating limits. Only we have taken, but by that 2 constraints itself, it is taking more time. It is taking more time to solve. Even if you take some complex constraints into consideration, then the complexity will be increasing like anything. will be that might be some of the most complex problem like you ever solve, like that. It might be that. So we are going for certain we are compromising certain constraints. We are not considering certain constraints. We are compromising in certain terms, and we are going to find out, like that. Like that you can do, like that you can do. But if you take in all the constraints, and that might be one of the most complex problem that you ever solve. Okay, so now we are going for like complex terms like AI PGA cube plus BA PGA square plus CI PGA plus DA, like that. If say for example the fuel cost function itself will be framed like that, then we are going for adopting this gradient method. Okay, so what is gradient method? Gradient method algorithm, that is one of the algorithm. In that you can simply solve that same problem with some certain steps, only some five or six steps. You can easily solve that, solve the problem, and you can attain the answer easily. What is the first step? Step one, select the starting values for PG1 naught, comma PG2 naught up to PGN naught. Okay, so initial values we are selecting, like previously we considered. Now we consider certain values for like say for example 1000 megawatt demand. We consider certain values for PG1 assumed, like 500 megawatt. Second generating unit is 300 megawatt. Third generating unit is 200 megawatt. Like that we assume. Now similarly, what we are going to do is we are selecting the certain initial values, some values for like a PG1, PG2, PGN. Like initially we are considering, so we are taking it as like 0 or not. Okay, PG1 not, PG2 not, like that. We are taking the initial values such that it meets out the demand. The demand is very, very important. We should not consider like any values. Demand it should satisfy. Okay, so 1000 megawatt means like first generating unit 500 megawatt, second generating unit 300, third generating 200, like that. It should meet out the demand. Without meeting out the demand, don't simply consider certain values and don't simply solve. Your answer also will come wrong. It will not satisfy the demand at last, and answer also simply like the wrong one. Next, step number 2. What is the step number 2? Step number 2 is compute lambda naught. Compute lambda naught. That is lambda naught is equal to dfi divided by dpi by substituting pi. By substituting pi, here PGI also same, PI also same. So lambda naught is equal to dfi divided by dpi by substituting pi for each generating units using this equation. So this is the step number 2. So first step number 1 is select the initial values for the generation, that is power generating unit, that is PG1, PG2 up to PGN. That is not, that is initial values. We are taking it as PG1 naught, PG2 naught up to PGN naught. Next, step number 2 is compute lambda naught. Lambda naught, that is dfi divided by dpi by substituting pi for each generating unit using this equation. That is the step number 2. What is the step number 3? Step number 3 is compute the initial average incremental cost. Initial average incremental cost using this formula, that is lambda is equal to 1 divided by n, summation I is equal to 1 to n lambda I naught. Already we calculated lambda I naught. Here we are taking average. Like already we know like how to take average. So how many generating units? That is divided by n. Okay, say for example n generating units if you are taking, so whatever the value, that is lambda I naught divided by n for all the generating units you need to take. Okay, don't simply take for first generating unit or second or third, fourth, like that. For all the generating, whatever the generating units that is participating in that dispatch, in that particular dispatch. Say for example in particular dispatch 100 generating units we are taking. The 100 generating units you have to take, you have to add and you have to take the average. So here what is the n here? N is nothing but 100. Okay, so lambda 1 naught plus lambda 2 naught up to lambda 100 naught. Okay, that the whole thing you need to add, and you need to take average. That is, you need to divide by nth generating unit. That is 100 generating unit. Like that, you need to calculate. So initial average incremental cost. That is 1 by n summation I is equal to 1 to n lambda I naught. Next step. Step number 4. What is the step number 4? Compute the gradient. Compute the gradient by using this formula. So for gradient, we know how to find out the Lagrange's function. Lagrange's function is defined as objective function plus some constant. Here we are taking lambda into constraints. Objective function plus lambda into constraints. Okay. So constraints already we know. PD, like a power balance constraints, PD minus PA. PD minus PA. So here Lagrange's function is equal to summation I is equal to 1 to n Fi of PA. That is, we need to minimize this total fuel cost plus lambda, that is constant, into constraints, the power balance constraint, PD minus PA. Okay. Next, how to take a gradient. So gradient of L is equal to, so this is gradient of L. This is del L. So you call as del L. So del L is equal to dou L divided by dou P1 up to dou L divided by dou P1 n. That is dou L divided by dou P2 up to dou L divided by dou Pn. Okay. Again, we are adding this dou L divided by dou lambda also we are adding over here. And here, if you see, what is the answer for this dou L divided by dou P1? Directly, we are taking the answer. That is df1 divided by dp1 minus lambda. And for dou L divided by dou P2, df2 divided by dp2 minus lambda. So up to PD minus PI. PD minus summation I is equal to 1 to n PA. Okay, so that also in one okay matrix we are taking all, we are calculating all these values. That is del L is equal to dou L divided by dou P1 up to dou L divided by dou Pn, and this answer, that is dou L divided by dou P1 is df1 divided by dp1 minus lambda. Okay, minus lambda. Again, this so while calculating, while simplification, we are getting this df1 divided by dp1 minus lambda. So up to PD minus PA. So this power balance constraints also. So if it has to come 0 here. Okay, this is without considering the losses. So here it has to come 0 here. Why? Because see, if all the generating units satisfy the demand, say for example, demand is 1000 megawatt. After finding out P1, P2, P3, like we are considering here we are considering the value for P1, P2, P3. So here, say for example, I said no, P1 is equal to 500, P2 is equal to 300, P3 is equal to some 200. So while adding all this thing, it is coming 1000. So 1000 minus 1000 is 0. Okay, so if in this matrix it is coming last thing, it is coming like 0, then the demand is satisfied. Defaultly, the demand is satisfied. So no need to verify once again whether the demand is satisfied with the generation or not. Like that, no need to verify. Okay, if this value comes 0, then while seeing problem, we can easily know. We can easily know this. So now you just take down this. So here, if it is 0, then demand is satisfied. That is the gradient of L. So gradient of L, directly you can take instead of this. You can, if you know, or otherwise you need to okay, you need to derive this. That is dou L divided by dou P1. So if you calculate dou L divided by dou P1, already we did this. So that's why I skipped this step. Why? Because so you can also calculate dou L divided by dou P1. So dou L divided by dou P1 na. So this term, that is df1 divided by dp1. So this term will come df1 divided by dp1. So demand, already we have seen, no, demand is more. So we are neglecting this demand. So lambda into 0 minus 1. So this this term, that is PD term, becomes 0. So lambda into 0 minus 1. Okay, so here after simplification, it is coming coming like minus lambda. So df1 divided by dp1 minus 1. That so simply like that we have taken. Or otherwise you need to derive that, you need to differentiate, and you need to find out that also well and good. Well and good. You differentiate and find out this value, or otherwise directly you can take this value. That is del L, gradient of L. Next, what is the step number 5? Step number 5 is select a scaling factor alpha. Select a scaling factor alpha for this alpha for convergence. Okay, so this is you have already seen in C program. Some convergence factor you will be taking. Otherwise, your C programming, if you are not taking the convergence value, whether which point that a particular program has to stop, like that one alpha you'll be taking some values like convergence factor, some 0.1 or something, some values you'll be taken. If you didn't taken this, I think in C programming you have seen this. If you didn't taken that convergence point, that program will run for n times. Okay, it will keep on running. It will not stop. Say for example, addition of n numbers or something, you are doing a program. That program will not stop. Iteration will not stop. Simply like that, it will run. Okay, the tolerance limit, like similarly like tolerance limit. The tolerance limit we are not giving now. Simply like that, the program will run for n times. Like it will be running. So until otherwise, if the tolerance limit not mentioned in that program, if the tolerance limit mentioned, if this value reached some 100, then stop the program. Like that, if we didn't mention, until otherwise it will stop. If it is reaches 100, it will stop. Otherwise, that program will run for n times. So similarly, like that, the scaling factor. Okay, the scaling factor also for this program, like while doing program, you can easily know the same thing. You can also do it with MATLAB program and also with the C program also, because C program or some Java or Python program. So whatever the program you can do, like if I give the algorithm, you need to program. Whether the platform might be of different Python or C++, C or whatever it may be, but you need to do that. Nowadays everyone is doing programming with the Python programming. So similarly, if I give the algorithm, you can easily program. Okay, so like that, then the tolerance limit, here it is scaling factor. If it is not mentioned in the program, that program will run for n times. It will keep on running. So similarly, this is the scaling factor. So scaling factor alpha for convergence. We need to select the scaling factor alpha for convergence. Otherwise, this program will run for n times. Next, step number 6. Compute the new values for the power generation using this equation. New values for the power generation using this equation. That is x dash is equal to x naught minus del, that is del L into alpha. Del L into alpha. Del L into alpha. Del L already we calculated. And what is the scaling factor? Alpha. Alpha we already considered. That also we need to take into the thing. Okay, so x dash is nothing but x naught minus del L into alpha. So we are having 6 steps. Only with the 6 steps, easily we can find out the answer. So this is the initial. While doing the problem, we can see clearly. So this is the initial values. Initial values what we consider. This is the calculated value. This is the calculated value. This is the initial value. So all together we are getting in the single matrix itself. Okay, so previously we need to like a lambda iteration algorithm, also some 7-8 steps. I think 7 or 8 steps. We need to verify all the things. We need to go to the first thing, and we need to consider once again the values, then repeatedly. So that is somewhat complex. So in this gradient method, so within, I think if you neglect this step number 5, scaling factor alpha and all, then further it might be coming 4 steps only, because the first step what is select the starting values of PG1, PG2, PG3, that up to PGN. That also we have taken into account. So if we neglect this two steps, I think only 4 steps. Within the 4 steps, you can find out the answer very, very easily. Why? Because the complexity is like many algorithms. What we are doing is we are going for more algorithms, and then by reducing the complexity, which reduce the complexity and time being involved. See, previous lambda iteration method, we are taking around 20 minutes, 25 minutes for solving a problem. Okay, so if you solve in gradient method only 4 steps, no, I think that 4 steps also is very easy. Okay, within 20 minutes, it might be reducing to some other 10 minutes or 15 minutes, so that you can easily solve that problem. Easily solve that problem. So that is the one advantages in this method. So number of steps is being decreased, and also time involved is being decreased. Okay, so within the easy, like the programming, if you program this the same thing in MATLAB programming or Python programming, then within the like a number of seconds, say for example lambda iteration method, it is taking some 1 or 2 seconds for completing 10 iterations, like that. So in this gradient method, it is the seconds, 1 second, say for 60 minutes, sorry, 60 seconds, 1 minute, it is taking 60 seconds to complete 10 iteration. Means if you are doing the same algorithm, same thing with the gradient algorithm, it might be reducing to some further some 20 seconds, some 40 seconds itself, you can easily get the answer. So how fast you are getting the answer, that is very, very important. Why? Because in load dispatch centers, you are starting. See, in load dispatch center, you can't take the paper and pen. Say, for example, in our load dispatch centers, say 30 generators are connected. 30 generators, you can't write the cost function. Then what is the demand? Say demand is 15,000 megawatt. What is the first generating unit? What is the cost function of first generating? Like that, if you calculate for 30 generating units, I think it will take, say, if you are doing it with pen and paper, I think minimum it will take some 5 to 10 hours to solve 30 generating units. 10 hours if you solve that problem, then how will commit the generating units? How you will commit the generating units, which is the least cost generator, and from that how much you can generate the power, like that, how you will select that might be taking some so like half an hour, like that, if you take now again, like it will be taking 12 hours. Okay, or 24 hours in a day, 12 hours itself taking for calculation and computing and selecting the generating units. Means then see the complexity, the whole day, half a day will be completed. Then when you will generate the power, when you will give to the consumers, then 12 hours, the entire state or entire your what are the loads that is being connected to the load dispatch center will be in, not getting the power for 12 hours, for half a day. Then the very, very time consuming. So for that, if you program this, simply if you give the data like in an Excel sheet, if you simply give the data like see what is the demand. Demand is in the program itself, you just enter what is the demand. Say for example, today's demand is 15,000 megawatt. So what are the generating units? Cost function. If you predefine, you know the cost function of each thermal generating unit. Say for example, 30 thermal generating units is there. 30 thermal generating units, you already know that is predefined for each generating units. So in that, easily you can enter the values in a Excel sheet already there. If you take, then this is the demand. So which are the, so in that, if you give into the program within 60 seconds or within some 2 minutes, okay, you will get the answer. What are the least cost generators? Say for example, generator 1, generator 5, generator 8, 10. then 12, some 15, some 18, 19, something like that. These are the risk cost generator. Like that, the program will give the output. So based on that, you from the load dispatch center, you can simply communicate to your generating station. So which generators you should on for how many hours. Even time constraints, time also I didn't take into account. Time also will be taken. Our problem will become more complex, more complex. Okay, even this itself very complex. If time also will be taken into account, how many hours this particular that is more complex. You need to program. Programming is more and more complex. Okay, so you need to program and see in that program, that particular program will give the output for how many hours that particular generating units it should on. Say for example 5 hours, first generating units 5 hours, some fifth generating units some 8 hours, some 10th generating units, or some other generating units for 12 hours. Like that, it will clearly give the time also. So no need to calculate how much time it should be on, and so that it will meet out the demand, like that. So even if you go for whole like only thermal, we are speaking. If you program with together, combine together, like thermal, hydro, wind, solar, then some biogas, some other nuclear, everything you pre-program. These are the installed capacity. These are the running generating. Say for example, installed capacity already we program, but today's running condition, which are the generating units in running condition, that also if you update in that program, it is very easy. Like within 5 minutes you can get what are the whole, like which thermal, hydro, nuclear, then some other thing. So which are the generating units today need to participate for how many hours? First generating unit for how many hours? Then second for how many hours? Like that. So which are the least cost generator? So I need only least cost generator. If you select all the generating, if you select the costliest generator, then the amount involved in generation will be increased. Again, the tariff bill, that is tariff to the consumers, will be increasing. So that is also will be if you choose not, it will be very easy for to select the generating units and to run the generating units for particular hours of time, everything. Even say for example, the demand is not constant. Even that also, if you take like each and every hour, the demand is varying. Like that, we are predicting like that. We are inputting the data. Again, that complexity of the program still increases, because each and every hour the demand is varying. So each and every hour, based on the demand, it has to select the generating units. Say for example, simply like that, or otherwise in that same program also, you'll be given with some other option also. So demand might be, we are predicting one demand, but practically it is increasing. So in that, say instead of 1000 megawatt, I'm just entering 1200 megawatt. Okay, so 200 megawatt, simply like that, increasing. So again, that program has to choose whichever the generating units it should on. That is least cost generator unit, it should on. So we need to communicate to that particular generating unit, so to on for some 2 hours, or for 4 hours, 5 hours, like. Okay, so like that, you should program. So like that only your state electricity board are acting. Okay, so they will not simply sit and calculate this is the demand. They will predict this is the demand. So which are the generating units you should on? So again, resources also you could add in this program. Resources, wind velocity, then what is the thermal coal unit, how much tons we are having the coal, and what is the amount of water we have, what is the nuclear power generation we are receiving today. Like that, also you can add. And what is the amount of velocity of the wind, okay, what is the intensity of the light, so that how much megawatt of power we can generate from solar PV. Like that, if you simply input, then everything within 5 minutes or 2 minutes you can get everything data. So which are the generating units? The solar means which is the least cost generator, which you need to generate. Solar almost least cost only. So wind also almost least cost only. But based on the wind velocity, you should select wind velocity. I said previously, the wind velocity is low, then the efficiency will be decreasing. In that scenario, even if you generate also, that is loss. Okay, like that, everything if you program, it is very, very easy task for you select and your generation, and the cost also will be minimized. With the minimum cost, we can generate maximum power, and as well as the consumers also will get reliable supply 24/7 or 24 hours in a day. So without any interruption, you should give the power to the suppliers, that is consumers. Okay, that should be the main aim for your generation companies or distribution.